Force of 100 pounds and a force of 130 pounds have an angle of 52 degrees between them. Find the resultant force and the angle between the equilibrium and the 100-pound force. Students are really not good at this. All right, this is a very commonly missed, probably the most common missed problem on the test. So let's make sure we can handle this. So you've got a 100-pound force and a 130-pound force with an angle of 52 degrees between them. So first of all, you got to be able to draw the picture. Okay, that's what they're talking about. Find the resultant force. Well, the resultant force, this is a dog walker problem. So to do the resultant force, you have to do the parallelogram rule. That's the resultant force right there. That's what the resultant force looks like. So in order to do the resultant or the parallelogram rule, we use things that we know about a parallelogram, like this side is 130 over here. And we don't really need the side over here, this 100, but whatever. I'm trying to get a triangle out of this parallelogram. If this angle is 52, first of all, notice that it's not split down the middle. Those two angles would be different, okay? But what we would know is that this angle right here is going to be 180 minus 52. Those two angles, 52 plus this, what would that be, 128? Those two angles have to add up to 180, okay? If you can get there, then you should see side, angle, side, and we should be able to do law of cosines. This is case 3. This is case 3, law of cosines. To find this side right here, okay? So law of cosines case 3 says r squared equals 100 squared plus 130 squared minus 2 times 100 times 130 cosine of 128. Notice I did not use 52, I used 128. Okay, that's not our answer because we're going to end up having to take the square root. R squared equals 42907.1. But we want to take the square root of that. Square root, second answer, 207.1. R is approximately 207.1 pounds. That's the resulting force. That's the resultant. Okay? So this is a hard question for people. Find the resultant force and the angle between the equilibrium and the 100-pound force. So this question is really weird. The equilibrium is right here, and it's supposed to be equal and opposite to that resultant. I didn't quite have enough room to make it look equal, but it's equal and opposite. But what they want is this angle between the equilibrium and the 100-pound force. Now, you can't just use the 52. So this is a difficult question. And so a lot of times people will say, well, 52, that's 26 and 26, but that's not true because this thing is not split in half. The resultant doesn't go right through the middle of that 52. It's probably more like 25 and 27 or something like that, but they're not the same, so don't assume that they are the same. Basically, you have to find whatever this angle is. This angle is different than this angle. You shouldn't have to find them both. You should just have to find angle B, or I mean angle A. Angle A here. So angle A we can find using the law of sines. So I would say sine A over 130 equals sine 128 over R, which was about 207.1. So let's do our law of sines to find that angle. Cross multiply. Divide by, I'm going to divide by the answer so I don't have to round, 207.1, blah, 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 blah. That's 0.49. I'm going to do an inverse sine to find A. It's 29.6. Okay. A is 29.6. I'm not going to have to do the second half of that equation. All I need is the first angle. A is 29.6 degrees. Okay, remember when we thought it was 26? It's not 26, it's 29.6. So then all we have to do to find this angle is notice that this is supposed to be a straight angle. That's a straight angle, or 180. So this angle right here, theta, is 180 minus 29.6. 150.4. Students really struggle with that question. Okay, moving on. Convert from polar form to rectangular form. So these should be easy because it's just using the formulas, but students really struggle because they don't know when to use which formula. When they want rectangular, that means they want x and y, and that's consistent all throughout this chapter. We want x and y. So what's x? Well, x is our cosine theta, and y is our sine theta. Okay, so now, if you're using a calculator for this, you shouldn't be, but you get some kind of nasty looking number, and that's probably because it should have been in the chart. There's probably a square root in there. So if you just do cosine 45, it shows you that you should have used the chart. That's 0.707. 0.707 is one of those numbers that we know, square root of 2 over 2. So that's really 50 times square root of 2 over 2. You can cancel. It's going to give me 25 square root of 2 right there. Sine 45 turns out is the same thing. So we're going to get the same thing, 25 square root of 2. So rectangular form, you're going to have your x component plus your y component with an I in it. Rectangular. You've got an x and a y. So then the next one, it's really the same thing. You're going to have to do r cosine theta plus r sine theta with an I on it. Okay, that's going to be rectangular. And it's pretty obvious that that's not going to be in the chart. If it's not going to be in the chart, then that's just a calculator question. 964 cosine 154 and 964 sine 154. Negative 866.4 plus 422.6 with an I on it. Okay, rectangular. Rectangular has an X number and a Y number, so that means you'd go left and you'd go up. That puts us in the second quadrant, but so does this. Okay, 154 is in the second quadrant. Either way you look at it, whether it's in polar form or rectangular form, second quadrant. Okay, so then the other one, convert from rectangular form to polar form. Rectangular was XY, polar is R and theta, or R cis theta. So we need R and theta. So your equation for R is going to be the square root of x squared plus y squared. 9 plus 16 is 25, so we do the square root of that's 5. R equals 5. Your tangent theta equals y over x. Looks like that. We're going to have to do an inverse tangent of that. This is not in the chart, so we can use a calculator. Inverse tangent, negative 4 over 3. Gives me negative 53.1, okay? But that's not really negative 53.1. It's 53.1 negative. What you've got to force yourself to do is remember to look at where we are, okay? Where are we? And so when you look at this, 3 negative 4 takes you right and down. That puts us in quadrant 4. So I don't want you to say this answer is negative 53.1 because it's not. It's not negative 53.1. It's 53.1 in the fourth quadrant. So we would look at this and say, well, all the way around past 270, not yet to 360. We can do what? 360 minus 53.1 is 306.9. Theta is 306.9. So if we put this vector in polar form, we'd say 5 cis 306.9 degrees. That's polar. Polar has an r and a theta. So then the next one, r equals square root of 81 plus 144. That's 225, I believe. Is that right? Yeah. So square root of 225 is 15. Okay. Tangent theta equals 12 over negative 9. That actually reduces to 4/3, so maybe you can tell that that's going to be 53.1 again. But I don't know, maybe you don't see that. Inverse tangent 12 over negative 9. That's the same thing. Okay, but it's not in the same quadrant because that takes us left and up. Left and up puts us in quadrant 2. So we've got a 53.1 in quadrant 2 this time. So that's 180. That's right before it's 180. So this time we do 180 minus. $126.9. So theta is 126.9 there. Answer 15 cis 126.9. Okay, dot product. Here's another very commonly missed problem. People don't know what the dot product is and what it does and what it says. Okay, find the dot product. It's really one of the easier questions on the test, but people will miss it. 3 times negative 1. Okay, if you do a dot b, so you're doing 3 negative 2 dot negative 1 negative 3. You multiply the x numbers. 3 times negative 1 is negative 3. And then you multiply the y numbers. Negative 2 times negative 3 is 6, and you add them together. The answer is a number, okay? And that dot product number describes the angle between the vectors, okay? Since that's a positive number, I know there's an acute angle between the vectors. But the second half of that question says find the angle between the vectors. Okay, dot product tells me that the answer is going to be an acute angle, something between 0 and 90. But the formula for this looks like this, and people get confused by this, but just remember that we're talking about the dot product over the magnitudes. Dot product of each vector, dot product of the two vectors divided by the magnitudes of each vector. Okay, so the dot product we just found was 3. Cosine theta equals 3 over. Now the magnitudes, the magnitude of this one, square root of 3 squared plus negative 2 squared. That's square root of 13. So the magnitude of A is square root of 13. And the magnitude of B is going to be negative 1 squared of negative 1 squared plus negative 3 squared. That's square root of 10. Okay. Might be difficult for you to type this in your calculator, so I would recommend putting that in parentheses. Oops, just happened. Nope, don't want to do that. Do that. 3 over parentheses, square root of 13, close them, times square root of 10, close them, and close that bottom. Gives me that number, 0.26, but cosine theta equals that 0.26 number. So we do an inverse cosine. (74.7). Theta equals 74.7 degrees. Okay, remember when we said it was going to be an acute angle? There we go. Okay. Part B, same question. Find the dot product. Well, the dot product, you take these two, that's negative 24, and you take these two, that's positive 24. You add them, you get 0. That's your dot product. This 0 tells me that this is something called orthogonal, or in other words, it's a 90-degree angle. So honestly, I don't even need to do that formula. You could use the formula again, but I already know this is a 90-degree angle. Dot product of 0, 90-degree angle. Okay. Simplify. Polar form is kind of easy because you can just multiply 6 and add 240. As long as we're staying in polar form, you're done. If you had to convert, you'd have to do your r cosine theta plus r sine theta with an I on it. But we're leaving it in polar right here. When you divide, you have to divide and subtract. So again, very simple if you know what you're doing. Next problem looks like de Moivre's. De Moivre's theorem, you take 5 to the third, and you take 40 times 3. So that's going to be 125 cis 120. I really like polar form because the math is pretty simple. That's actually supposed to be part D here. And that's definitely the hardest one because it's not in polar form. We would love for that to be in polar form, but it's not. One thing you could do, I suppose, is do what you would have done in algebra class and just distribute it out. Okay, that's one thing you could do. Or if you want to think about trig, you can do change this to polar and then do de Moivre's. So polar form, we need r and theta. So r would be square root of square root of 3 squared plus negative 1 squared. That's going to be 3 plus 1 is 4. Square root of 4 is 2. R is 2. R is 2. Okay, then tangent theta equals the y number over the x number. Now, you guys should be good enough at the chart that you know 1 over square root of 3. 1 over square root of 3 is going to be a 30. Okay, that's a 30 reference where tangent is negative. But you notice right and down puts us in quadrant 4. So that 30 negative is in quadrant 4. This must be 330 degrees. And so all that work was just to change this to 2 cis 330. We still have to take it to the third power, but that's where de Moivre's comes in. 2 to the third power is going to be 8, and then you do 330 times 3, which is 990. 8 cis 990. That's the answer in polar form. If you wanted rectangular form, you'd go 8 cosine 990 and 8 sine 990. So 0 minus 8i. 0 minus 8i is the answer in rectangular form. Okay. Find and graph the resultant of these two vectors. Okay, well, A is the vector 7 plus 3i. 1, 2, 3, 4, 5, 6, 7 plus 3i right there. Do not go past that dot right there. B is negative 2 plus I. Negative 2 plus I is right there. Do not go past that dot right there. This is A. This is B. So what we could do is the parallelogram rule and see that that vector is going to go to the opposite corner. But what we probably need to do is just add the parts. 7 plus negative 2, 3i plus I. The resultant is 5 plus 4i. So 1, 2, 3, 4, 5. 1, 2, 3, 4. There is our resultant. Let's put this one back. Okay. Oops. So again, your parallelogram rule, it should have knocked to that corner right there.